Hello Year 9s. In this video, I'm going to go through the script learning task that was given to you. I will read through and explain what the questions mean, and I'll show you some data that I did and draw the graph. Watch the video and self-assess your work in green pen. Okay, so the work that was given to you is to look at the motion of a Coca-Cola can down an inclined slope from different heights. So in the image that is given, you've got the inclined slope here, which is basically this. That's the inclined slope. That's the can, ruler, and that'll be the flow, and you use some books or anything that you can support this plank. Now, before I start, I must say I tried to do this practical with starting at 10 centimeters and then 20 and 30, but it got pretty high too soon. So what I decided was to go with start at 5 centimeters, right? 10 centimeter, 15 centimeter, 20 centimeters, and 25 centimeters. I did 5 heights going up to 25 centimeters. So in this experiment requires the measurement of distance traveled by a can when rolled off a plank of wood or cardboard. You will start from ground level 0 and record the distance traveled by the can along the floor in centimeters. You will then have to increase the height of the plank of wood, cardboard every 10 centimeter. Here, instead of every 10 centimeter, we did 5 centimeters. And repeat the experiment 3 times for each height and find the effects of height on how far the can travels. By the end of the task, you should have 1 table of data and 1 scientific graph. So you needed a drink can. It could have been any bottle. As long as it rolls down, it's fine. A plank of wood or cardboard, a measuring tape, or a meter ruler. So, planning. What are you trying to find out? I'm going to investigate how the height of, actually let me just type this up, it'll be easier. So here's the typed up answers. Now your answers doesn't have to be exactly the same, but I'll tell you which ones can be different. So for the first one, I'm going to investigate how the height of the ramp affect the distance traveled by the Coke can. That has to be the same. Prediction, describe what you think will happen. Now my prediction is, which doesn't really have to be too much different to what you did. I predict that as the height of the ramp increases, the distance traveled by the can would also increase. Using your knowledge and understanding of science to explain why you think this will happen, I believe this will happen because as the height increases, the starting energy, now you would have learned about gravitational potential energy in year 7 or even in primary school, most of you, of the can will also increase, which causes it to travel further. Variables, what will you change, measure, and keep the same? Now the variables that I would change is the height of the ramp. Remember, I'm choosing 0, 5 centimeters, 10, 15, 20, and 25 centimeter height. Variables to measure is the distance traveled by the can, and the variables that I would keep the same is the ramp, the flow that I'm doing this test on, and the can that I'm using as well. Fair test. Explain how you will carry out a fair test. What equipment or features were you going to keep the same? How many times are you going to do the test? By using the same can and ramp on the same floor, this will make sure the friction because I'm trying to explain, I need to say why. This will make sure the friction between the ramp and the can is the same throughout the investigation. Now they've also asked how many times, right? I will do it 3 times, right? I will do for each height of the ramp, I will do it 3 times. Now in the space below, list the apparatus you will require. Now the list of apparatus is already listed on the top. Draw a diagram. So let me just draw the diagram quickly. So here's the diagram. I've got the box, box supporting the ramp and the can on the top, and I'm going to start measuring the distance traveled from the edge of the ramp to wherever the can will actually roll off up to, and write a step-by-step plan of how you will carry out this investigation. Set up the investigation as shown in the diagram. So since I've drawn the diagram, it was easier to just simply say I'm going to set it up as shown in the diagram. Then I will let go of the can from the top and wait till it stops rolling. Next, I will measure the distance the can rolled. Right? It could include using a ruler in brackets, so we can describe the equipment that we are using as well. Roll from the bottom of the ramp and record it in a table, and then I would repeat it 2 more times for the same height, and finally repeat the above steps for height 10 centimeter, 15, 20 and 25. Explain how you will make sure your results are reliable. How will you know the results are accurate? To make sure the results are accurate, I will repeat the investigation 3 times to get 3 distances for each height of the ramp. Then I will calculate an average for the distance traveled. If I think any of the results are not correct, I would repeat it and ignore the incorrect result in my calculation. So what I'm trying to say here is, let's say I roll it when the ramp height is 5 centimeters. First time I get 7 centimeters, second time I get 7.5, and the third time I get just 4 centimeters. I know that I got 7 twice, so 4 is probably wrong, so I would ignore that and do it again till I get a distance which is similar to 7 centimeters in length. Success criteria. How will you know if your investigation was successful? Now, I should get similar distance traveled for each height, right? Because the energy of the can at a certain height doesn't change, so I should get very similar distance traveled by the can. The distance traveled should increase as the height also increases, and the graph should show a positive correlation, which is basically a line going upwards. Explain why you would have chosen these as your criteria. Now, part of the hypothesis at the start I said is, as the height increases, the distance traveled also increases, so I'm using the same thing. This was part of our hypothesis at the start, and from our scientific investigation, the more energy and scientific understanding, the more energy the can has, the more distance it would move. Now, here's the set of results that I did and I got. So I've got the height in centimeters in the first column, starting at 0, going all the way up to 25, increasing in 5 centimeter height. I've done it 3 times, first trial, second trial, third trial, and then the average distance traveled, which is in centimeters. As you can see, I've repeated it till I got very similar results. So if I got, let's say, anything different to 36, I would have actually ignored it and repeated it again. Now, what you're supposed to do is to draw a graph based on your average distance and the height. Now, here's a look at the graph that I drew. So in the bottom, I've got the height of the ramp, which is my independent variable, goes up into 5, 10, 15, 20, 25, 30. I didn't do 30, but I labeled it 30. And the distance traveled, maximum it went up towards 36 point something. So I went up to 10, 20, 30, and then 40. And then I plotted the points. So at 5 centimeters, the average distance was 7.4. At 10 centimeters, the average distance was about 13.5, and at 15 centimeters it was 21.5, right? 21.5 is slightly different. I need to move that. Oops. Right. Right. Sorry, I've just realized that this was slightly off by about a box error. The rest of the points are correct, and as you can see, the whole graph, the line is going up, and when the line goes up like this, we call it a positive correlation. Right, let's get back to the analyzing data and making conclusions. Using your data, describe any pattern. Now this depends on how your graph turned out to be. Based on my graph, so the results show that the higher the ramp, the more gravitational potential energy the can would have. The more energy the ramp, oh, that's a mistake there. With more energy, the can will move further. The graph shows a positive correlation. To make your investigation valid, you must have carried out a fair test and have accurate results. Comment about how valid your results are. Again, it depends on how you did your practical. In my practical, the results are valid since the results for each height were very close to each other. If you're getting similar results for each height, then your results are also valid. Comment about how reliable your results are. I think our results are, I think it is fairly reliable as it was repeated 3 times. Suggest how you would make the investigation better and even more accurate. Well, if I want to, I could repeat it for more heights, or I can compare my results to others in the classroom. Did you achieve your success criteria? Explain your answer. Yes, since the results were as expected, and I can write a bit more explanation if I want to. That brings us to the end of the video. Watch the video, pause whenever you need it, and then mark your work.